Hello and welcome to a tutorial on using SC segmentation for tomogram segmentation. This is the software as it looks when you first open it up, and I'll briefly run you through the user interface and then show you how to do manual annotation and then training of neural networks and then exporting processed volumes. So first of all, I'll drag two files onto the viewer to import them, or you could have gone to File and then Import Dataset. And these are cryo-electron tomograms acquired with an Arctica microscope on samples that contain liposomes decorated with antibodies and C1 on lacy carbon film. So you can see membrane, protein, and lacy carbon. You can close the datasets header, and then there's the filters one, where you can adjust how the scene is rendered. You can change the contrast settings, interpolation, and you can add filters if you would want, but we'll leave those out for now. So let's start segmentation. The first step is to manually annotate a section of the dataset. So add a feature, let's call it membrane, and let's start drawing. You can see that this cursor has appeared, and if we click and hold and drag, we draw. Let's increase the alpha a little bit. And right-clicking is erasing. Let's zoom in, do so holding Shift and scrolling the mouse wheel. You can pan by pressing the mouse wheel and dragging the scene around, and you can change the brush size by holding Control and then scrolling. So let's make it more appropriate for a membrane segmentation. Zoom in a little bit extra and start drawing. This is not going to be super accurate. We'll just do a quick annotation and then a simple model just to show you how it all works. If you want to erase a bit, right click and hold. So there we go. Let's change the view to make it a little bit clearer. Zoom out. And then the next step is to start boxing up images for the training dataset. So we'll want a number of boxes that contain the feature of interest, and here they'll overlap a little bit. So that would be 28 boxes. And then we also want negative samples. So let's call this other feature not membrane. Make it red just to be extra clear. And then box up other stuff, so carbon, which is bad, out of focus carbon, and then some ice particles, background noise, and maybe some reconstruction artifacts that can be seen in the further away slices. So that's 47 negative boxes. And if you ever want to find back the slices that you've annotated, you can hover this button over here, and then in the active slices view you can just click it and you'll be back at the annotated one. So hide the boxes for now. That's the first step, the annotation. And we'll only do it for membrane for now, and there'll be a more involved tutorial on doing multiple models later on. So next step is to go into the second tab, the models one, and to create the training dataset. So open that header. Features of interest will use membrane as a positive sample, not membrane as a negative one, and we can sample both tomograms. The first one doesn't have any annotations at this point, but that's fine. 64 pixels for a box size is usually good. You can try 32 to make it faster, or 128 to make it perhaps a little bit more accurate, but also a lot slower. And then 13.92 angstroms per pixel is the size of these datasets, so that's fine. Generate set. Menu opens that asks you to save the training dataset somewhere. So do that. You can see it's done. Then go to models, add a model. You can call it whatever you like, or just right-click the name field to select any of the earlier features. A membrane with the same color. We'll use UNet Deep for a model. That's the default one. It works pretty good, pretty well. And then browse to find your training data set. So there we go. 25 epochs, 30% negatives, 32 batch size, 4 copies is the default setting, and that usually works very well. So train. First time can be a bit slow because that's when TensorFlow needs to initiate all kinds of stuff, and I had already done that before, so here it's a bit faster, but usually you may have to wait 10 or 15 seconds. And you can see the loss go down and the training progress bar fill up, and then within maybe 30 or so seconds the model is done training on a fairly small training data set, so it could have taken longer for a bigger one, of course. And then you can start browsing the data set to see the segmentation result. You can actually also do that during training to see the model get better. So go to the prediction tab, maybe increase the alpha a little bit, decrease the threshold to see what it thinks is membrane. And as you can see, it's picking up the edges of carbon some protein as well. But again, this is a minute of work, so usually you would spend some longer to try to make it work better. We can change the overlap, which is when a slice gets processed, it's first chopped into square images that then get fed into the neural network. And then the result gets detiled back into the original image shape. And the overlap is the overlap between these adjacent squares. So if you set it to 0, it's much faster, as you can see. And if we set it to 0.67, which is the maximum, or you can actually override it by control clicking and, let's say, put it to 0.95, but now it's going to be pretty slow. It's processing now. Maybe I shouldn't have done that. Ah, there we go. So, a lot slower. And I accidentally scrolled, so it's processing another one. Right, but let's set that back down to 0. In the filters header, you can additionally also crop the image and specify which bits you want to segment and which you want to ignore. So let's use this for now. And then with an overlap of 0, which isn't ideal, but it can work, you can see that the segmentation is pretty fast. So, that being said, we'll skip the interactions tab for now because we only have a single model, but that will be included in a later tutorial. And let's continue on to the export tab, where you can specify which models you want to include, so membrane, which datasets to process, let's do both, and then for both of them, let's additionally also limit the range. So when you check that one, you can see these two sliders appear down here, with which you can say that we would only want to process these bits, because all this other stuff is just out of, well, not out of focus, but it's not actually within the sample, these depths. So, there we go. Let's do that for the other one as well. Something like that to here, it's fine. Crop it a bit. Up. And then start export. So when that bar fills up, that means one tomogram is done. So that would have been the first one, and then the second one. And then usually what we do is import those segmentations into Chimera X to play around with them a bit and see how well they've worked. And I'll append a Chimera 3D rendering at the end of this video.